In this exercise, we're going to be looking at vertical translations, that is, movement up and down the y-axis. And that on our equation is this bit here, plus or minus b. The other thing that we're actually going to be doing as well is finding our x-intercepts. And we're going to be using the method that we worked through in the previous exercise for solving equations in order to find these intercepts. 30 plus. In this example, we're asked to find the x-intercepts and then to sketch the graph. So let's do that first. Let's find the intercepts first. And like in all graphs, finding the x-intercepts, we let our y value equal 0. So x-intercept, let y equal to 0. All right, so you get 0 equals minus 2 sine 2 theta plus 1. All right, we want to get the sine 2 theta by itself, so let's bring everything over the other side. So bringing the 1 over, it becomes minus 1, and then divide by the minus 2 gives us sine of 2 theta. So of course, that is simply sine 2 theta equal to positive 1/2. Now let's work out what quadrants we're actually going to be in. Notice that our angle is a double angle, so therefore 2 theta is going to be between 0 and 720 degrees. So if I'm working the quadrants, okay, I'm looking for when sine is positive. So it's in the first and second quadrant, but I am going around twice. So I've got another 2 solutions there. Basic angle is our next step. Basic angle is always a single angle, and it's a single angle in the first quadrant. So sine theta equal to 1/2. Now remember, I'm working in degrees here because my question is in degrees. Sine theta equal to 1/2, we should know that theta is equal to 30 degrees. All right, is that an answer I'm going to accept? Yes, because it is in the first quadrant, and I want my answer in the first quadrant. So therefore, 2 theta is equal to 30 degrees. What is my next solution? Well, I'm in the second quadrant, and that is what? 180 minus theta. So 180 minus 30 degrees. And then to each one of these first two, I just have to add on 360 degrees. Because remember, I'm going around one full rotation from that one to get to that one. So I'm going around 360. So 30 plus 360 is 390 degrees. And this one here, 180 take away 30 was 150, plus 360 makes 510 degrees. So 2 theta equals 30 degrees, 150 degrees, 390 degrees, 510. And of course, I don't want 2 theta, I want theta. So theta is 15 degrees. It is 75 degrees. It is 195 degrees. It is 255 degrees. They are, in fact, now my x-intercepts, and they are between 0 and 360 degrees. The other thing that because I'm going to be drawing this graph, the other thing that I actually want to work out here is my trend and my amplitude. And perhaps where I might start. Now we can see here, if I come over here a little bit, you can see that the trend here is going to be upside down because I've got a minus. So it's an upside down sine graph. So rather than going up, I'm going to go down first. I'm going to go up and back. So my graph will look like that. That's the trend of my graph. All right, the other thing that I'm going to find is my amplitude. Now my amplitude is 2. The minus sign doesn't affect my amplitude. And usually when my amplitude is 2, I'd go between minus 2 and 2. This is where your y translation now changes that. Your y translation, you're moving everything up 1. So that's going to be plus 1, and that's going to be plus 1. So y now is actually between minus 2 plus 1, which is a minus 1, and 2 plus 1, which is 3. My amplitude is still 2, but my graph has now moved up, and we're going to do our guidelines in a minute. There is no x translation there, so I'm pretty much ready to go and graph. So let's do our guidelines. You can see that I'm going between minus 1 and 2. Minus 1 is down there, and 3 is up there. So between minus 1 and 3. Now the middle of that is at 1. So that is where my graph is going to oscillate around. I also know that I want my graph to start at 0 and go to where? Well, let's work out the period of this graph. The period is 2 pi on n, or 360 on n, and my n value here is 2. So the period of this graph is actually 180 degrees. So one full cycle of this graph, okay? That's the box there. That's where I'm going to draw one full cycle of this graph. So let's get to business. We have our x-intercepts. We know we have one at 15 and 75. So let's start sketching this graph. We know that our graph always starts from the middle. So there is my middle point for that. It will go back through the middle and then end up in the middle. However, because this is a minus, it's going to go down and it's going to go up. My x-intercepts are in the middle here, yeah? And we know that the other one is 75, which is in there. So our graph, which goes down like that and up, and then it's going to go up and come back down again. That's one cycle, and there's our x-intercepts there. Same thing is going to happen again here. I'm going to go all the way to 360, so there and there. I've got to go down first, and then I'm going to go up. All right, middle and middle for my x-intercepts. So there, I'm going to go up, and I'm going to go down. Okay, I should, in actual fact, identify my x-intercepts on my graph. So that one is 255 and 0. This one here is 195 and 0. That one there is when theta 75 and 0. And that one is at 15 and 0. Any points that you go through, like any graph, you should actually identify. So there is the graph of -2 sine 2 theta plus 1 between 0 and 360. So a lot of work involved for one question. In this next example, which we'll call B, we're asked to sketch the graph of y equal to √2 sine x plus 1 between 0 and 2 pi, and we are going to start off the same way by finding our x-intercepts. So x-intercept, let y equal to 0, and 0 is equal to √2 sine of x plus 1. So you can see that we're going to have a y translation. Let's get everything now over to the other side and get sine x by itself. So you get -1 on √2 is equal to sine of x. Or let's just look at it this way. Sine x equals -1 on √2. Now, do we need to change our domain at all? No, we don't, because we don't have a double angle here. You can see that we're dealing with x, and we know that x is between 0 and 2 pi. So looking at the quadrants that are involved, we know that we're dealing with sine of x being negative. And where is it negative? It is negative in the third and the fourth quadrants. So let's get to our basic angle here. Basic angle is sine x. And remember, we only ever take a positive. We want the angle in the first quadrant. So it's 1 on √2. Sine x equals 1 on root 2, which means that x is equal to, now we're in radian, so x is equal to pi on 4. Is that a solution that we're going to take? Well, unfortunately no, because our solutions are in the third and fourth quadrant. So therefore, x is equal to, in the third quadrant, it is pi plus theta, so pi plus pi on 4, and in the fourth quadrant, it is 2 pi minus pi on 4. So they're my solutions, and I worked them out. So 4 plus 1 is 5 pi on 4, 2 pi, which is 8. 8 minus 1 is 7 pi on 4. They are my x-intercepts. Obviously now I've got to find some other things, so let's keep going and let's look at the trend of this graph. Is it upright or inverted? And it is upright. It's a sine graph, so it's just going to look like that, a normal sine graph. What is the amplitude of my graph? Well, amplitude here is root 2. And we know therefore that y should be between minus root 2 and positive root 2. But of course we have our y translation. It is translated 1 unit up. So I'm going to add 1 to that and 1 to that. So obviously now it is going to be a roundabout-ish, because root 2 is 1 point something and minus root 2 is minus 1 point something. So we're going to just put that around about on our axis. So I've worked them out on my calculator, and that's what they come out to be. But of course you can think about that in your head as well, because we just want a roundabout. Now the other thing that we probably should consider here is the period of this graph, and we know that the period is 2 pi on n, and n in this case is 1, remember, between the sine and the x, so 1 full cycle is 2 pi. Let's start putting that together with our guidelines. So 1 full cycle is 2 pi, so really that's all they're asking for in this graph, is for us to draw 1 full cycle. All right, so that's from there to there, and I might just change my axes here, because I'll take that as a minus 2 and minus 4, and make that 2 and 4, because I do need to go to 2.4. So where is negative 0.41? It is around about there. And where is 2.4? Okay, it is around about there. Let's continue sketching our graph. Now the middle of that would be at 1, which is in there. 2, 4, 6, 8, 10. So let's draw it. The sine graph starts in the middle. Okay, it goes through the middle and ends up in the middle. And because it's upright, it's going to go up there and down to that point there. Okay, and we know that we've actually worked out our x-intercepts. Obviously, on this side here, it doesn't cut the x-axis, but it cuts the x-axis there and there. So is that 5 pi on 4? Yep, 5 pi on 4 and 0. And this one over here is 7 pi on 4 and 0. So that is the graph of root 2 sine x plus 1 between 0 and pi.